Alrighty, hello my darlings. We are starting our right triangle chapter, and the first thing we're going to look at is a reminder of the Pythagorean theorem, but there is a new thing to it. We are going to be looking at the Pythagorean inequality theorem, which is basically the inverse of the Pythagorean theorem. So just our basic Pythagorean theorem. Remember, if we have the sides of a right triangle, then the legs are A and B, and the hypotenuse is C, and we get A squared plus B squared equals C squared. We also have these things called Pythagorean triples. This is when the three sides are all integers. So two really famous and used a lot Pythagorean triples are a 3, 4, 5 and a 5, 12, 13. And due to the fact that we just finished similar triangles, any multiple of these would also be a Pythagorean triple. Like if I multiplied these all by 2, I would get a 6, 8, 10. That would be a Pythagorean triple. If I multiplied all of these by 3, I would get a 15, 36, 39. That would be a Pythagorean triple. So anytime the three numbers are all integers, then it's called a Pythagorean triple. So example 1, find the missing side and then decide if they form a Pythagorean triple. And I forgot, I don't know how, but I didn't get numbers here, so you're going to write in, we have sides of 6, b, and 9. So 6 squared plus b squared equals 9 squared. Square the 6, square the 9. B squared equals 45, so b equals the square root of 45. This is not a Pythagorean triple. The square root of 45 is not an integer. They are the sides of a right triangle. They're just not called a Pythagorean triple. Okay. All right, so here we have a, 8, and 10. So a squared plus 8 squared equals 10 squared. Square the 8, square the 10. A squared equals 36. If you take the square root of 36, you get 6. So in this case, yes, it is a Pythagorean triple. 6 is an integer, 8 is an integer, 10 is an integer, so all three sides are integers. All right, so the Pythagorean inequality theorem, or basically the Pythagorean theorem inverse, is we can decide what type of triangle we have looking at a squared plus b squared and comparing it to c squared. Just like up here though, C is always the longest side of the triangle. In these two cases, it's not the hypotenuse, because the hypotenuse is specific to a right triangle. It's just the longest side. So if we plug it in and do a squared plus b squared, and we don't get an equal sign, but we get the fact that a squared plus b squared is bigger than c squared, then that tells us this third side is smaller than it would be here in a right triangle, so that means we have an acute triangle, because this angle is no longer a right angle, it got smaller. If we do a squared plus b squared and we find out that that is smaller than c squared, well, that means this third side got even bigger, so we now have an obtuse triangle because this angle opened up and became bigger than a right angle. So example 2, decide if the sides form a right triangle, acute triangle, or obtuse triangle. So remember, it doesn't matter what order you're given the sides in. C always has to be the longest side. So C is the square root of, or is 26. So 10 squared plus 24 squared, and I'm comparing it to 26 squared. Well, if you plug this into the calculator, you get 676. If you plug this into the calculator, you get 676. That's an equal sign, so that means we have a right triangle. Okay. Up here, 14 is the largest number, so that's going to be C. So 9 squared plus 12 squared, and I'm comparing it to 14 squared. Well, this becomes 225. 14 squared is 196. Well, 225 is bigger than 196, so that means we have an acute triangle. And that's it for Pythagorean theorem. Thanks, folks.